Friends, welcome to our channel. Let's look at problem 3820, Pythagorean distance nodes in a tree. In this video, we are going to do it via breadth first based traversal. And the key point is to help you understand the logic. So here we are given an undirected tree with n nodes numbered from 0 to n-1. In other words, this is zero indexing. So the tree is represented by a 2D array edges of length n-1. So here n nodes n-1 edges because it's a tree, right? So we are also given three distinct targets nodes x, y, z. So for any node u in the tree, we consider dx be the distance from u to x, similar for y. Then a node u is called special if the three distances form a Pythagorean triplet. A Pythagorean triplet means this, right? So we want to find all those nodes. Actually, here we should return the counts. So you can look at example 1 and 2 here. They have very detailed explanation. So here the constraints are the following. First, n is bounded above by 10 to the power 5. And x, y, z are pairwise distinct. So the input is generated such that edges represent a valid tree. So those are consistency assumptions. And this here, the first item, gives us the problem size. So the key consideration here is the following: how to get distances for each node to x, y, z respectively, right? So if you run a breadth first traversal from a source to x, y, z, for sure you get the distance from that source to x, y, z respectively. But because the number of nodes in the tree is very large, let's say given by n, you cannot run n times the breadth first traversal. Here the workthrough is that, so we use so here so here the key is use x, y, z as sources, and then you just run BFS for 3 times, right? And this way, once you get a distance from x to any nodes, then that distance is also the distance from that node to the x or to y to z, right? That's the main point. So once you realize this point, and then coding out this problem will be a very standard exercise. So here our procedure will be the following. First, we build the graph. Second, we write a hyperfunction for BFS. So this is going to get the necessary information, that is dx, dy, dz, from x, y, z to any node. Lastly, we are going to do the return, prepare the return. In other words, checking the relation here, right? So with that said, let me finish the coding, and then we can do some test and share some comments. So the first step will be build the graph. So for build the graph, I'm going to use the default dictionary, right? Collections and default dict. So here I'm going to use a set, right? So this, some people use list. So here you can use set as a container, it will be sufficient. So basically for UV in edges, so the graph U, I'm going to add V, meaning that V is in the neighbor of U. So we also need to do the reverse direction because the tree is undirected here. Or in terms of graph, it's undirected graph. So once you have this, so this you finish the build of the graph, you can do some print to see. I'm going to use example 1 to give you a demonstration, right? Here, let's see. unexpected indent. That's the special Gauss solution, and then this will be good. And then let me check this. And then tab. So let me try again. Unexpected indent. So let me copy this part and then I'll do it again. So I'm going to reset those. Yeah, let's see if this will work. Yeah, so here you can see for example 1, so 0 1 0 2 0 3, so this is the neighbor of 0 and then the reverse directions, right? So with that said, we finished the first step, and then the second step will be write the first traversal function, BFS hyperfunction. So for this is also very standard. So let's we accept a source, and then also we accept a tree or graph, and then what we want to do is to get all the distances here. For this purpose, I'm going to use this collections default dict, and then I'm going to use a lambda function to do the initialization. So I'm going to use this. So this basically is the distance from the source to the corresponding nodes, originally set to be positive infinity, right? And this result as a dictionary actually plays two roles. It also helps us to avoid repetition. So in general, if we write BFS function, you also need a set to avoid repetition. So here, let me write the logic. So here, because we are going to use breadth first traversal, so I'm going to use a queue. So collections, I'm going to use a deck. So the deck going to accept nodes and the distance to the source. So originally it's like this. So the distance of the source to this node, the source itself, is 0. So basically what we store is pairs node and the distance of that node to the source, right? So then standard while loop. So basically node and distance is going to be q pop left. I'm going to use the left as the queue head and the tail as the queue tail. So then if result node equals float infinity, and then this means that we haven't visited this node before, and then we are going to add this result node equals the current distance, right? And then we are going to check the neighbors. So for neighbor in graph node, and then we want to check if result neighbor equals float infinity. This is to make sure that we didn't visit the node. We haven't visited the node before. If this is the case, so we're going to append this information to node, and the distance will be the previous distance incremented by 1, right? So this way, we are going to return the result state. So after the role of this function is that, so given a source, and then you are going to run through a breadth first traversal, then you are going to get all the information of the distances to that source. So now this is the second step. The third step will be do the return. So for this, actually, first we get the distance from x to nodes. Basically, you do BFS from x to every node. So then y to nodes. So BFS y graph. And then z to nodes. So BFS z graph. And then we are going to do the counting. So result to be 0. And then basically for node in range n, right? That's the name of the nodes. So let's first get the distances. So the distance is going to be so x to nodes So here this is a dictionary, so we call node and y to nodes. So we're going to get the same node, and similarly z to nodes. We're going to get this node, and then in order to check this, because if this condition holds, the absolute value of a and b should be no larger than that of c. So we're going to use a sort. So this tense is sort. First do the sort, and then do the check, right? So if this tense is 0, the square plus, let me copy this. This tense is 1 square. If this equals distance is 2 or -1 square. So this means it satisfies the condition. So we're going to increment this by 1. And then we just need to return the final quantity, right? So with that done, I guess that's the full code for this problem. So we can do a run for test. Yeah, it passes the 3 test cases. So now let me submit. Yeah, it passes all the cases. So here, I guess a comment is that the major thing is that we think in the other direction. So we do traversals using x, y, z as the source. So this way, we only do 3 times of the whole very first traversal, right? So with that said, I guess that's it for the current problem. If you have comments, you are welcome to let me know, or you can visit our YouTube channel to practice more.